This is solving quadratics by factoring. So we just spent a whole chapter on factoring, so that should help you with this section. So the first thing we have to know is something called zero product property. And it's where you have two groups equal to 0. You can set each one equal to 0. And then you can solve. So here I would add 7 to both sides. We're going to get x equals 7. And then on this one I'd subtract 2 from both sides. So we're going to get x equals negative 2. In the next one I'd have x minus 2 equals 0 and x equals 0. So one's already solved for me. The first one I'd add 2 to both sides and I get x equals 2. Okay, now I have to solve by factoring. So the first thing I need to notice is that a quadratic equation has an equal sign. It always has to be equal to 0. So that's what I need to start with. So I have it equal to 0, and then I have a trinomial. It doesn't have a GCF. When we factor, we always check for a GCF first. Then I check how many terms it has. Since it has 3 terms, I'm looking to see if a is 1, or if a is not equal to 1, or maybe if I have a perfect square trinomial. In this case, a is 1. When a is 1, I can just set up with my x, and I need 2 numbers that multiply to c and add to b. So I need to multiply to 8 and add to negative 6. Well, I could do my product sum table if I want. So to multiply to 8, I have 1, 8, and 4, and 2. And this is the one that adds to 6, but I have to focus on the negative. So to multiply to positive 8, it was either a positive times a positive or a negative times a negative. So I know that both of these have to be negative 2 to sum to negative 6. So negative 4 and negative 2, I put in my equals 0. Now zero product property, I set each one of these equal to 0. And now I can solve. So add 4 to both sides, I get x is 4. Add 2 to both sides, and I get x equals 2. So remember, for a quadratic equation, I need it equal to 0. So I would start by subtracting 21 from both sides. None of these are like terms, so I just write it as x squared plus 4x minus 21 equals 0. Or you can just know that when you move 21 to the opposite side, it's going to become the opposite sign. Okay, from there I need to factor. Well, again, there's no GCF and my a is 1. So I need 2 things that multiply to negative 21 that add to 4. So if to 21 I have 1 and 21, or 7 and 3. So I know it's 7 and 3, but to add to 4, I need 7 to be bigger. So 7 and negative 3 are my terms. So x plus 7, x minus 3. Now I set each one equal to 0, zero product property. Subtract 7 from both sides, x is negative 7. Add 3 to both sides, x is 3. Next one, it's already equal to 0. So I can just start factoring. You might realize that we have a difference of a perfect square trinomial here. That square root of x squared is x, the square root of 36 is 6, and this is 2 times x times 6. So you could just take the first sign and square it and make it equal 0, which really means I have x minus 6 times x minus 6 equals 0. Set each one equal to 0 and solve. So add 6 to both sides, and it's the same equation. So really just have one solution, that x is 6. Now, if you didn't recognize that, you would always check for GCF first, and then you might notice that a is 1, and so then I need 2 things that multiply to 36 that add to negative 12. Well, that has to be negative 6 and negative 6. So realistically, I have the same thing here. Okay, for D, what I can actually do is just add 2x squared to both sides, so I don't have to move 2 things. And now I just have 0 equals 2x squared plus 20x plus 50. So that makes things easier. I can also pull out a GCF from all of these. It's the first thing I noticed. So I could take a 2 out of all of these. And so I have 0, put that in red, 0 equals 2 times, and let's see what I have left. I have x squared plus 10x plus 25. Again, I have a perfect square trinomial, but you might not recognize that, where I have x and 5 and a plus sign, so it would be x plus 5 squared. If you don't realize that, the GCF can be dropped down all the way, so we'll just put it right in front. And then it's a basic trinomial because a is 1, so I need two things that multiply to 25 and add to 10, so that would be 5 and 5. And now I have to set everything equal to 0. Well, I don't have to worry about the GCF equal to 0, because if you have 0 equals 2, it's nothing to be solved. So the GCF is kind of useless with zero product property. So instead I'm going to do x plus 5 equals 0, and the other x plus 5 equals 0. I'm going to subtract 5 from both sides, and I get x is negative 5, and the other one would be the same answer. So I'm just getting x is negative 5. Okay, for the word problem, the height and feet of a diver above the water can be modeled by this equation. Where t is time in seconds after the diver jumps off of a platform. Find the time it takes for the diver to reach the water. Well, reaching the water would be a height of 0. So that's where I can plug in my 0. Then I see that I have a GCF here. I can divide all of these by, let's take out negative 8, so the leading coefficient becomes 1, even though the GCF isn't negative in there. But I'll show you why it's helpful. So now I have a positive 2t squared. So that tends to be a little bit more helpful if that leading coefficient is positive, especially if it came out to a is 1, positive 1. So negative 1t and negative 1. So I need, let's put my GCF here. This is where it gets a little confusing. So I'm going to need to use the AC method. So I need two things that multiply to negative 2 that add to negative 1. Well, the only things that multiply to 2 are 1 and 2. So to end up with a negative 1, it had to be 1 and negative 2. So I have splitting the b to 1t and negative 2t. So I have 2t squared plus t minus 2t minus 1. Remember, I'm kind of ignoring the GCF for a little bit here. I have to worry about factor by grouping right now because I have 4 terms. So I'm going to be taking out a t, and I have 2t plus 1. Then I'm going to take out a negative 1 so that I have 2t plus 1. There's my GCFs and my twins. And I had a negative 8 in front and a 0 equals. And now to solve, I don't have to worry about the 0 equals negative 8. And then the t minus 1 equals 0, 0 product property, and 2t plus 1 equals 0. So I add 1 to both sides, I get t equals 1. All along so far, the solution has just been the opposite of what's here. Like I said, a negative 1, it's 1. It doesn't always work that way, because if you have a two-step equation, like I have here, I get 2t equals negative 1, divide by 2, then t equals negative 1/2. We can't have a time of negative 1/2. It doesn't make sense. So then I'm just going to keep that t is equal to 1, and this was time was in seconds, so 1 second.